Okay, so here we go with the alkynes part 2. So I told you in the previous meeting that the alkynes, they can be hydrated in two different ways. So I'm going to use one of those white pages to illustrate the difference when using the Markovnikov reagent, so the mercury salts under acidic conditions, or the second method, which is the borane followed by hydrogen peroxide. So here we go. Let's say that you have an alkyne. Let's say that you have an alkyne that looks like this. So this is 1, 2, 3, 4, 5. So this is one pentyne. So if I add water under the Markovnikov conditions, that means in the presence of mercury salts and acid, what is going to happen? Well, because it's a Markovnikov process, the OH will end up in the second carbon atom. This is my carbon 1, carbon 2. Why? Because the hydrogen in the hydration, remember hydration, we are adding water, right? The hydrogen will end up on the carbon atom that initially had more hydrogens, which is the carbon number 1, right? So, and then the OH will end up in the carbon atom that initially had less hydrogen atoms, which is carbon number 2. So that means I will end up with a compound that contains 2, 3, 4, 5 carbon atoms, and I will get initially an enol. The OH will be in the carbon number 2, and the hydrogen ended up in the carbon number 1. But because we can go through this process that we call tautomerization, so then there is an equilibrium here between the keto and the enol form. So this will tautomerize into the keto form. This is the enol form. This is the keto form. How about if we were performing this reaction in the presence of BH3 and then followed by hydrogen peroxide under basic conditions? Because it's a non-Markovnikov process, the result will be that the OH will end up on the carbon atom that is on the tip of the molecule. That will be the initial enol product that I will obtain. That will be the initial enol product that I will obtain. And then after the tautomerization of this, the result will be 1, 2, 3, 4, 5. I will get an aldehyde. So there you can see a big difference between the reaction, under Markovnikov conditions, mercury salts, and with borane followed by hydrogen peroxide, while the method with mercury salts will give you a ketone as a final product. The method with borane followed by hydrogen peroxide will give you an aldehyde. Okay. So notice that the tautomerization process is something that goes like this, right? So we have, let's say, if you have an enol that looks like this, the tautomerization process will be simply that you can have a base that helps you to abstract a proton. You form an enolate, still have a double bond there. And then now you can bring the pair of electrons down. Then you can localize the pair of electrons there. And then now, once you have the pair of electrons on the tip of the molecule, and you already have your carbonyl group, so the base that had captured a proton and had formed BH plus, so then that same base protonated can help you to deliver a proton back on the organic compound in a different place, right? So then now this is capturing a proton, and we are forming now the protonated form of the ketone, and then the base becomes the base without the protons again, right? So you get the keto form, and you started with the enol form. And so that oral process is what we call the keto-enol tautomerization. Keto-enol tautomerization. It is a rearrangement reaction in essence, because the molecular formula is the same, but the attachment of the groups is different. There is a big difference between a tautomerization and resonance structures. In resonance structures, only the electrons are located in different positions. In the case of the keto-enol tautomerization, there is a hydrogen atom here, a particular hydrogen atom that was relocated in a different place. So that hydrogen atom is on the first carbon atom there, right? Okay, so, and then here in the next slide, we have the mechanism of this reaction with mercury. So first we have the reaction of the alkyne, the pi bond of the alkyne reacting with the mercury 2+. And then now, once you form a carbocation intermediate, water can attack that carbocation intermediate, and you will form the enol form here. We still need to get rid of the mercury, right? And that the way to get rid of that mercury is by reaction with the H3O plus. H3O plus will provide the proton that will replace the mercury in that place, right? And the final product after the tautomerization will be the ketone final product. So just to wrap up, let me just give one more example. Let's say that we have a terminal alkyne like this, and I react this with mercury salts, mercuric sulfate, water, and acid. So the overall result that I will get will be still a 1, 2, 3, 4 carbon atom compound, 4 carbon atom compound, and because the reaction is Markovnikov, the oxygen will end up in the second carbon atom. If I was performing the same reaction and the same starting material, but with BH3 followed by hydrogen peroxide under basic conditions, the result will be that I will get a 4 carbon atom compound, still a carbonyl group, but in this case it will be an aldehyde. And here is a ketone. Okay, so I'm making my videos just very short, because otherwise I cannot upload them on YouTube. So here, this is the end of my second part of the chapter of alkynes.